Alright, so let's take a look. I'm guessing you just went 5x equals 10, 2y equals 10, and divided it out. You get 2, 0, and 0, 5. And that is correct. 0, 5 right here, 2, 0 right here. I'm not an artist, but I'm going to do my best here. That's good enough for me. How are we doing? How many people got that one right? Okay, good. Let's go to the next one. You guys tell me, what's my x-intercept? -5, 0. And my y-intercept? 0, 4. And again, look, I don't even have to write stuff down. When it's divisible, I can just go like this. Oh, -20 divided by -5 is 4. -20 divided by 4 is -5. Sweet. Here, here. Boom. How many people got them both right? Sweet. This is easy, like I said. All right? Now, let's move on to the next page. Because, well, actually, wait. Before you do that, let's fill this out right here. What if it doesn't go in evenly? And you're going to see in the next page they don't. And I'm not talking about one of them. I'm talking about both of them. I'm sorry, other way around. I'm not talking about both of them. I'm talking about one of them. One of them might actually fit in perfectly. The other one doesn't. If you get a decimal, that gets really weird. Okay. So, what do you think?
Or divided?
Kind of. We're gonna actually. What do you think?
I think you're gonna divide by both sides by x.
And that's not wrong. But I think we're even overthinking it a little bit. All you literally, and both of you are kind of on the right track actually. You're just going to solve it for y. Because all of you know how to graph y equals not what it's supposed to be. Right? I mean, we did that on 6-1, right? So literally right here, we're going to solve it for y, put it in that slope-intercept form that we talked about up here, and then graph using the y-intercept and the slope. And of course the slope is rise over run. Let's see what I mean. Let's go to the other side. So we've got problems here that, like I said, if I look at number 4, you can see in number 4, well, number 4, the y would divide evenly. I would just get -4, but -4 divided by 3, anybody know -4 divided by 3? What that would equal as a decimal? 4/3. Yeah, so give it to us. What's it say? Did you do it, Priscilla? Did you divide 4 by 3? I'm sorry, no, I'm the other way.
Is it 1.3?
Excuse me. Yeah, sorry. 1.3. Sorry. I'm still getting names. We'll get there. So 1.3 repeating. So, but that's really, like, where do I graph 1.3? Is it like,
between?
yeah, it's between, but I would rather be exact, right? And that's why I don't want to use the cover-up method when I can. If I just solve this for y, what would I do to solve this for y?
Get the y on one side.
Get the y on one side. So what can I do to get rid of this?
3x, take away 3x from both sides.
That's exactly right.
Yeah.
Just minus 3x. Now here's where some of you are going to get confused. The 3x is canceled here. The y comes down. Can I combine -4 and -3x? No, why not? Yeah, one has an x and one doesn't, right? They're not like terms, right? So that's not -7x. It's not -7 either. Matter of fact, let me put it in perspective. That would be like combining $4 and 3 apples and saying I got 7 apples, right? I can't do that. So instead, I could either write -4 minus 3x, or if I wanted it in slope-intercept form, which is y equals mx plus b, well then I should put the x term first, -3x minus 4. Well, now you guys know how to graph that. Where do I start? Yep, that's a good idea. Let's put that over 1. What's the first point that I plot? -4. So again, that's the y-intercept, right? The y-int is at -4. So I go there. And then I use my slope. And so Ronnie, you started it. So -3, 1. But this kind of, what happens here? I go down 1, 2, 3. I go over 1. But that's way off my graph.
You can go up 3 and then over -.
Exactly. So what I'm given, remember I said you always go right, right? You always go right. So I go down 3 and right 1. But if it's off my graph, let's just go the exact opposite way. And if I go up 3 and left 1, then I stay on my side. If I go up 3 and right 1, I get a Pac-Man. These are lines. These are not Pac-Mans. Okay? So let's go the exact opposite way. Up 1, 2, 3, left 1. Up 1, 2, 3, left 1. Now really, how many points do you have to have a line? 2. I only did 3 because I'm trying to show you something. Watch what happens. I'm going to connect my dots here. If you just did 2, you can do 2. That's plenty good. But I was trying to be really precise here for a reason. Because look what happens. See this point right here? That's negative 1.3 repeating. We said that's what it was going to be. The x-intercept was going to be negative 1.3 repeating. But rather than being kind of like it's kind of here, it's kind of here, it's kind of here, this makes it precise. Okay? Let's take a look at the next one. Because the next one doesn't work out quite at 3. What do I do first? Just solve for y.
Move to the other side.
Move it to the other side. Move the x to the other side. So I'm going to move the x to the other side. I get 2y equals, again, I'm going to write it in mx plus b form, negative 3x plus 8. The difference between this one and the other one is negative 4 was minus, positive 8 is plus, right? Now what? Now how can I solve this for y? That's exactly right. If I just did this, you guys would all know, oh, we just divide by 2. Even if that x is there, we just divide by 2. But what we do is everything divided by 2. These will cancel. Y equals, we can leave that. That's rise over run. We want a fraction there, right? And then plus 4. I am not going to give you numbers that don't divide nicely. The slope might not, but that's okay. We can do rise over run. But here, I'm not going to give you a 4.2 repeating. That's ugly. Okay? So, let's graph that. Up to 4. Down 1, 2, 3. Which way do I always go?
Right.
Right. 1, 2. Done. Done. I'm going to do it again just because I have to be precise. But you only need 2 dots. As long as you're going in the right direction. And boom. Done. What do you think? Not so bad?
So that's your answer?
Correct. My answer is the graph itself. Okay? You guys try the last one. You guys try number 6. All right, let's take a look. So, first things first, we got to bring that x over. Remember, we got to do the opposite there. So that becomes a negative 5x. Those cancel. 3y equals negative 5x plus 3. And of course, I divide by 3. To everything, y equals negative 5/3 x. That's okay. Plus 1. So again, the y is where I start first, at plus 1, the number that's by itself. And then down 1, 2, 3, 4, 5, over 3. and connect my dots. And now you're going to use a straight edge. Now, what do you notice about all three of those graphs?
The corner, right?
They're all going like from left to right. They all look like they're going downhill, right? Anybody tell me why? Because they all have a negative slope. Negative slopes always go downhill. Positive slopes always go uphill. So if you're looking at your problem and you've got a negative slope, but your graph went uphill, you probably went left instead of right. Does that make sense? That's it. The rest of this page is your homework. So what you want to do is, probably what's easiest is either open them up or even just rip off this sheet and the graphs are on the other sheet, if that makes sense. So let's just kind of talk about one together. I see David did something that I kind of like here. So for number one, just use the cover-up method because I can divide them both, right? What does x equal? Cover that up. What is it? -5. What does y equal? 2. And so I go right to my graph for that, and I plot x to be -5 right here, my y to be 2 right here, and just connect my dots. And I just did the first problem for you. It's that quick. Now, where you're going to run into some issues is when you get to a problem like, say, number 7. Okay, let me just talk about number 7 real quick. Number 7 is a problem that you can do by just using the cover-up method, but you're going to get x to be 16. And these boxes only go up to 10. So how can I remedy that? Go by 2s. Right? Make your graph go up by 2s. Then you can do it perfectly, right? But if you do anything but 1, if you go by 2s, please make sure you label your graph. In other words, just like, so for number 7, here's number 7 here, okay? Maybe for number 7, I just put a 20 here and a 20 here so that I know you're going up by 2s instead, right? Instead of 10, it's 20 at that point. Then I know you went by 2s, okay? Now the only other thing, and I think there's one other problem like that, like 10. 10 kind of works out funky like that too, because you get x equals -20. Again, if you go by 2s, it works. Now the one thing I want to point out that I did not talk about is all of these have one line except for if you look at 10, 11, and 12. Well, remember when we did the 6-1 graphs, how you had one graph, and then you had another graph, and you had your point of intersection?
Yeah.
Same thing. 10, 11, and 12 is just graph that, then graph that. I'm not even looking for the point of intersection. I just want you to put 2 graphs on one, because that's going to get us kind of going to the next step to get us where we're going next week.
So none of these
Okay.
are these? So
Yep, some of those don't work out as well. Like if you look at number 8, 6 will go in, but 5 won't. So we'll probably want to do number 8 like we did at the top of this page. Same thing with number 9, because 5 doesn't go into 8 very nice.
okay.
So if you can divide them out perfectly, do that. For some people, as they're working on this homework, you got about 10 minutes left. I want to make sure I get the people who didn't finish their quizzes back. If you want, it's up to you how to do this. Some people just literally went through that page and found all their x and y intercepts or whatever and graphed it. Some people did the intercepts and then went to graph it, so on. However you do it, okay? All right. Go ahead and get to work. You got the rest of the time to work?